commonly called polysporin, but they inhibit gram-negative bacteria by poking holes in their membrane. All right? I'm sure you probably have neomycin in your medicine cabinet. If you take a look at the drugs that you have bacitracin, you have neomycin, and you have polymyxin B. Well, polymyxin B is like right over here. These are the ones that mess with, this is the drug that messes with bacterial cell membranes. Gram-negative, that is, all right? Daptomycin also pokes holes in membranes, except it's for gram-positive, all right? So whereas polymyxin E and polymyxin B, they poke holes in bacterial cell membranes, gram-negative, that is. Daptomycin, just like polymyxin, can mess with membranes, except gram-positive, all right? Okay, the next big category of things that can actually kill bacteria are antibiotics that affect protein synthesis. So think about it. If a bacterial cell cannot make proteins, guess what? They would be unable to grow. So this is a huge category. And let me just say just a few things before we get confused about it. This is what I want you to do, all right? When proteins are synthesized, as you probably know, ribosomes are the ones that do that job. So bacterial ribosomes make proteins, right? If you look at a ribosome, there are two subunits. So this is the huge complex that synthesizes proteins. There's a complex called a 50S, that's a large subunit, and there's a complex called a 30S ribosome. They have to work together to synthesize proteins. Well, here's the cool thing. We have antibiotics that specifically recognize 30S and antibiotics that specifically recognize 50S. Here's what I want you to know. I want you to know the differences, all right? So first of all, let's go to the two antibiotics that actually affect this one here, the brown structure. This is the 30S ribosome, aminoglycosides and tetracyclines. So these two groups of antibiotics mess with the 30S ribosome. For the 50S, I just want you to remember two of them, chloramphenicol and macrolides, all right? So really when it comes to protein synthesis, the 30S, we have aminoglycosides, and we have tetracycline. The 50S, we have chloramphenicol and macrolides. So let's talk about each of these. Again, we're looking at 30S ribosomes. What I want you to know is aminoglycosides target that. Several different examples, streptomycin, gentamicin, tobramycin, amikacin, neomycin. You find this in neosporin, by the way, and kanamycin. So these are all antibiotics that inhibit 30S ribosome. The other one, of course, is tetracyclines. So there are many different types of tetracyclines. They inhibit, just like aminoglycosides, they inhibit the 30S ribosome. I'd like you to make one correlation here. Prolonged use of tetracycline actually can cause discoloration of the teeth, as you see right over here, right? Tetracycline and aminoglycosides, they attack the 30S ribosome. Tetracycline actually can cause some collateral damage. Actually, it's more aesthetic than anything. It causes discoloration of the teeth upon prolonged use. All right? Again, tetracycline is 30S, aminoglycoside 30S. Let's look at the major groups that affect the 50S ribosome. Again, I'm only going to point out the ones I want you to know. Macrolides. Macrolides is a category that includes erythromycin. I'm sure you heard about zithromax, right here. That's called azithromycin and biaxin. So these are the three most important ones. Erythromycin has been around forever. The other two are relatively new, about 30, 40, 50, 40 years ago. Maybe 20 years. So again, these are macrolides. They inhibit 50S ribosome. Examples I'd like you to know: erythromycin, zithromycin or zithromax, all right? Erythromycin or biaxin as it's called. The other one that inhibits 50S ribosome is chloramphenicol. I just want to say a few things about chloramphenicol. It's a pretty cool drug, actually. It can kill many different bacteria. In fact, we don't use it a whole lot anymore, especially on kids and especially on newborns. Here's the reason why. All right, don't get me wrong. We can use this, for example, if somebody has meningitis or cholera or typhoid, or what we call typhoid fevers or typhus fevers. and also something called Rocky Mountain spotted fever. Again, don't worry about those diseases yet. We can use this, but nothing else works, all right? But generally, we try to avoid this because there's collateral damage, especially in kids, and especially in kids under 2 years old, and especially in newborns. Now, one of the conditions that we see is something called aplastic anemia. So we don't understand exactly why, but a few people who are on chloramphenicol, basically, their bone marrow cannot replenish their blood cells. So that's a problem. This is one reason why we don't use chloramphenicol too much. There's also a condition called Gray syndrome. This is a condition, especially on neonates, all right, newborn babies who are placed on chloramphenicol. They have cyanosis. They have this ashen gray color to their skin, cardiovascular collapse, low blood pressure, low temperature, vomiting, all right, and sometimes diarrhea. So again, these are conditions that can be very detrimental to the patient's health. But again, chloramphenicol is a pretty cool drug if there's nothing else to use. It does recognize the 50th ribosome. The problem that could be associated with this drug in younger people is aplastic anemia and then Gray syndrome. All right? These are also antibiotics. There are newer ones that affect 50S, but they're not of concern to us. I listed them here, so you can have a record of it. I'll talk about this drug here, clindamycin, when we talk about a disease caused by Clostridium difficile. You probably heard the word C. diff. I'm going to make a good correlation here when we actually talk about foodborne diseases a week or two from now. All right? This is a list, an extensive list of other antibiotics that actually affect 30S or 50S ribosome. Now, I want to move on. We're almost done. What about antibiotics that inhibit nucleic acid synthesis? So you guys all should know this. Nucleic acid refers to DNA and RNA. So I'm just going to give you really 3 examples I want you to know, all right? So first of all, rifampin, right over here. This is a drug that interferes with synthesis of RNA. Bacteria can't make RNA, they die, all right? So rifampin is RNA. One way I remember this is RNR because there's also DNA, right? So rifampin inhibits the synthesis of RNA. And then the last category right here, they're called quinolones. This actually messes with DNA synthesis. You probably heard this term before, levaquin, levofloxacin, or maybe Cipro, all right? These are prime examples right here, especially ciprofloxacin and levaquin. There are others that actually belong to the quinolone family. So these drugs, they actually inhibit the synthesis of DNA, all right? So those are the 3 examples, rifampin for RNA, for the quinolones, ciprofloxacin and levaquin, or levaquinone. All right, so here's a nice little table, summarizes everything I said to you earlier, all right? So remember, antibiotics are used to treat bacterial diseases, not viral diseases. Okay, so there are some other things on the slide. For the lecture part, I don't care that you can worry about this. In the laboratory later on the semester, you guys would actually be doing some tests against bacteria. You're going to see how bacteria respond to certain antibiotics. So don't worry about this part from the lecture. This is all laboratory stuff. Just to remind you, as I said this earlier, antiviral. All right? We're talking about 2 drugs you see on this table when we talk about viruses. Same with antifungals. These are not called antibiotics. These are drugs that you use to treat fungal diseases. They're called antifungals. I'm going to talk about these drugs later on when we get to the fungi. And then finally, antiparasitic drugs. These drugs kill parasites, all right, or they inhibit parasites and parasitic infections. They're not considered to be antibiotics. Remember, this antibiotics are specific to bacteria. All right? Okay. So, we're done with today's lecture. Have your attendance recorded. Don't be afraid if you have to go somewhere. You can log off, no problem there, all right? But I'm going to hang around for a little bit to answer any questions you might have. All right? We're done for the day. I will post a lecture on, now we're going to start talking about bacterial diseases. It's going to be chapter 11. That should be up and running tonight. And remember, you have a quiz on Wednesday, right? That quiz opens up 5 minutes before your official time period. Once you open that quiz, you have 10 minutes to complete that quiz. We will have a lecture after. Usually, I say 20 minutes, that's enough time for everyone to take the quiz and be ready to go for the WebEx lecture. All right? Okay, guys, I'm going to shut up now. And if you have any questions at all, go ahead and ask. Hopefully I can answer them for you.
Are we going to be tested on the antifungals and antiparasitic?
No. So only antibiotics.
Okay, I just wanted to check.
Yeah.
Yeah,
No problem. I know. I promise you, we wouldn't test you. I wouldn't test you on antifungals, antivirals, or antiparasites. We will talk about diseases caused by these groups of organisms later on, and I'll reintroduce those slides. But right now, I just want to focus on bacteria, because we're going to have 4 chapters coming up on just bacterial diseases. And I might say to you, penicillin. I want you to know penicillins attack bacterial cell walls, or they actually inhibit the enzymes that synthesize peptidoglycan. Excuse me.
So I was noticing, thank you. I was noticing at the end of the PowerPoints, there's usually a few or several slides we don't go over. Are those for lab or just extra?
Yes, exactly. Yeah. All right. So let's go to them again. So we talked about all this stuff. This is where this lecture stops, right here. All right. So that's what I'm going to hold you responsible for. Then we got to these slides. Actually, this one here. That's just a table to summarize everything. Then we got to these slides. This is what we'll be doing in the laboratory. I'm introducing a concept. How do we test antibiotics against bacteria? Well, we can use several different methods. Again, we're going to talk about something called MICs in the laboratory. So I won't test you that on this stuff. I'm going to talk about something called Kirby-Bauer. And this is the Kirby-Bauer. This would be done in the laboratory. Everything else past this slide is something we're going to discuss elsewhere. But I have them here for you for your reference. Does that make sense? All right, cool. Other questions?
How much of like the actual names do you want us to memorize, or is it just the ones that you said?
So, I got with antibiotics, right?
Mm-hmm.
All right, so let me show you why I don't want you to memorize a ton of them.
Okay.
Because check this out. This is inhibits protein synthesis, right? There are so many.
Mm-hmm.
But guess what? They're not common. So we can use them, but the ones that I pointed out as we went along, in fact, I put check marks on them, and I talked about them a little. Those are the ones that you see commonly used. Again, if I say to you, Zithromax, all right?
Mm-hmm.
Or Biaxin, or Keflex, or penicillin. Those are the ones that I want you to know.
Okay.
Make sense? And of course, not just the drug. I just point out very few problems that can be associated with them. Remember we talked about aplastic anemia, Gray syndrome. This is associated with plant. Right?
All right.
Those are the things I want you to remember. Because trust me, there are thousands of drugs, maybe hundreds that are currently in use, but I care that you know the more common ones because you see them over and over again when you become a nurse.
Okay. Thank you.
Perfect. Other questions?
Hi, Professor.
Hi.
Where are the recorded lectures going to be?
So I already placed a couple on Blackboard. They're going to be in combined sections. All right.
Okay, thank you.
All right. Other questions?
I have a question.
Yeah.
So you were talking about this bacitracin,
Yeah.
and you said that that's for when it's for like the cell wall. It prevents the cell wall synthesis. Do you only mix it with polymyxin B and not polymyxin E?
So that's a good question that you asked. So let's just go back to bacitracin first. All right. So bacitracin is a chemical or a drug that prevents this thing. It's called bactoprenol from moving across the membrane. All right. This thing, bactoprenol, is used to make cell walls. So here's the thing. Some people classify bacitracin as messing with cell membranes and cell walls. That's true. But it messes with, as far as the membrane goes, it messes with the transport of bactoprenol across the cell membrane. Ultimately, it prevents the synthesis of cell walls. Right? So the next question that you asked, in fact, to get to the point, is something called polymyxin. All right. Oh, I'm sorry. There's something called neosporin. You probably have this in your medicine chest. This contains bacitracin, neomycin, and polymyxin.